In this session, we'll explore some AutoCAD solid modeling fundamentals. Now, recently I picked up a 1970s-era desktop-sized Tinker Toy construction set. You can see some of my handiwork here on screen. The nice thing about construction sets like this is that the parts represent simple, repetitive geometric shapes. For that reason, they can be a great tool to help you develop your AutoCAD solid modeling skills. In today's session, we will model a spool from this set. That being said, the skills we learn here could be used to model the majority of the other parts as well. On my screen, I have two drawings. On the right, we can see a finished version of the spool. I created this so that as I enter dimensions later, you'll know where those dimensions are coming from. Over here on the left is a brand new drawing. We're going to create this spool from scratch. Let me mention that once I launched my AutoCAD, I loaded the 3D ribbon. I did that by opening the workspace menu, and I chose 3D modeling. Now, as I look at this spool, I see a cylinder shape. I also see a part that is in two halves, upper and lower. I'm going to start by drawing the lower half of the part. In the modeling panel, I will open the primitives menu and I'll choose cylinder. I will then hold my shift key and the mouse wheel and will orbit the screen slightly so we can see this in 3D space. I will then click to set the center of my cylinder. I know this cylinder has a diameter of 1.38 and it has a height of 0.35. That's because I'm only going halfway up. I will then zoom in. Now I know the spool has a hole that is drilled through it. We can see that here in the section view. That hole has a diameter of 0.25. Back in the view on the left, I'm going to tap the space bar to go right back into the cylinder command. I'm going to start my cylinder from the center of the bottom. This will have a diameter of 0.25. And then I will pull this up such that it's high enough to pass through the top of the part, and I'll click. Let's change the visual style. I'll do that by opening the menu, and I'll choose Conceptual. There we go. We can see that piece. Now let's subtract the second cylinder from the first one. Here in the solid editing panel, I'll launch the subtract command. I will select the larger part and press enter. I will then select the smaller one and press enter. And as I orbit this, you can see the hole passing through. I will then go back to this view on the right. Next, I'm going to create the filleted bottom. We can see that has a radius of 0.125. I'll do that by going to the Modify panel. I'll launch the fillet command, same one that we use in 2D. I will then click my edge. Now AutoCAD's asking me for the fillet radius. I'll type 0.125 and I'll press enter. Since this is the only edge I want to fillet, I'll press enter again. Next, we'll take a look at this beveled area. When I look at this, I see a chamfer. Looks like we're coming in 0.06 from the front edge, and then we're coming down 0.05. I'm going to click back in the drawing on the left. And then I'll go back to the Modify menu and we'll launch the chamfer command, same one we use in 2D. I will select the edge. When I do, it'll bring up this menu where I can select Next. You can see that each time I click Next, it will cycle through the faces that share that edge. It does this because if I enter two dimensions, it just wants to know which face represents the first dimension. Let me click Next. We'll start with this one. I'll click OK. And then my first dimension distance will be 0.06. Enter. My second distance will be 0.05. Enter. Finally, I will select that edge again, and I'll press enter. If I orbit this up, we can see that we have the bottom half of the part at this point. Let's come back and we'll zoom this out on the right side. To create the top half of the part, I'm going to make a copy. Here in the Modify panel, I'll launch the Copy command. I will select the bottom half and press enter. We'll pick this up from a point on screen, and then I'm going to tap the F8 key to lock my ortho. You can see I'm pulling this straight up in the Z direction. I'll click and press Escape when finished. Then to flip this over, I will select the upper part. Since I'm using a visual style that reflects light, we are seeing a gizmo. This happens to be the Move gizmo. If I right-click on this, I can choose Rotate. And then I can select a ribbon that represents the axis that I'd like to rotate around. I'm going to choose the red ribbon to rotate around the X-axis. If I tap the F8 key to turn off the ortho, you can see how this works. If I turn the ortho back on, I am restricted to 90-degree rotational increments, which makes it very easy to flip this over. I will simply pull in a forward direction here and click. I'll press Escape to deselect. There we go. Now we can put these two halves together. To make this a little bit easier, I'm going to change the visual style to X-ray. This allows me to see through the parts. Let's orbit this up slightly. I'll launch the Move command, and I'll select the top half, enter. I'd like to pick this up from the center of this hole at the bottom, and I'd like to place this to the center of this hole at the top. There we go. I'm going to flip this back to conceptual, and then we will union these parts together. I'll do that by going to the solid editing panel. I'll launch union. I'll select both of them, and I'll press enter. So now I have a complete solid object. The next thing I'd like to do is drill the holes around the outside. We can see those have a diameter of 0.25, and if I zoom out in this view on the right, we can see there's going to be 8 holes. If I pan this over, I can see that the depth of those holes is going to be 0.25. Let's start by zooming in this view. I'm going to change this back to X-ray momentarily, and I'm going to construct a polyline. In the Draw menu, I'll launch the Polyline command, and I'll create my polyline centered on the part. I'll shift right click and say mid between 2 points. I'd like to start my polyline midway between the quadrant here and the quadrant right below. I will then pull this polyline out. My ortho is still locked, and I'll click. If I orbit, you can see how this line is perpendicular to the part, and it's centered on that outside edge. Now let's create the cylinder that represents the hole. We'll come back to the primitive menu, and I'll launch cylinder. I'll start from the end point of my polyline. This will have a diameter of 0.25. And I don't want to draw this up or down. I'm going to come down to the command line and choose Axis Endpoint. This allows me to select the direction I'd like to draw the cylinder. I'll grab the opposite endpoint of my polyline. Now let's go to a top view. I'll do that by clicking the top hot spot on the view cube. Let's zoom in. I will then push this into the part. I'll launch the Move command. I'd like to move this cylinder. Enter. I'll pick it up from a point on screen. My ortho is still locked. I'm just going to pull this to the left, a distance of 0.25. That represents the depth of the hole. Now let's create a polar array. In the Modify panel, I'll open the Array menu and I'll choose Polar Array. I will select this part and press Enter. I would like to array it around the center of the spool. By default, we are getting 6 items. Here in the ribbon, I'll change this to 8 and I'll press Tab. Finally, I'll come over to the Associative toggle and I'll make sure this is turned off. I do that because I don't want this array to be editable using grips. I'm just going to subtract these out of this part as soon as I'm finished. So we'll make sure that's off. I'll click Close Array. I will then zoom out, and then I will do my subtract. We'll subtract from the spool, Enter. I'll tap F for fence and press Enter. And then I can click to create a fence, selecting all of the objects I'd like to subtract. I'll press Enter to finish my selection and Enter again to do the subtraction. Now that we're finished, I can maximize this drawing on screen. I'll orbit this up. Maybe we'll change the visual style to make this easier to see. We can also get rid of the unnecessary polyline. As you can see, in just a couple minutes, we have our first part. At this point, we could continue on and model additional parts like I've done here. We could then assemble those parts to create whatever we want. On screen is an example of just one of the possibilities. If you're interested in experimenting with or reverse engineering any of the drawings that I've shown here, I will provide download links to them in the description for this video. So if you are looking for a way to develop your AutoCAD solid modeling skills, consider replicating a classic construction set. If you want to take the concept even farther, see if you can improve on the set by designing your own custom connectors. The best part is, since you are working in a virtual environment, there is no limit to the size and scope of the models you can create. Would you like to explore other Autodesk infrastructure ideas and workflows? If so, please visit the Civil Immersion blog by scanning the QR code or by following the URL listed below.